Mr. Barry here talking about polynomials of higher degrees and talking about end behavior specifically. We need some information when it comes to degrees and leading coefficients to help us out with that. Here in this problem, we have y is equal to negative 5x to the third power plus 4x squared plus 2x minus 6. So we have four terms there. That would be a polynomial of four terms. I want to start out figuring out my degree. The degree here is the largest exponent we see attached to a variable, and in this case, that would be the number 3. Here's a 3, there's a 2, there's a 1, that's a constant, so there is a 0 for an exponent. 3 would be the largest number we see, so we'll go ahead and we'll notify that we have a 3 for the degree here. That would lead us word-wise to a cubic polynomial, so this would work out to be a cubic polynomial of 4 terms. But we also need to understand that while knowing that its highest degree here, the degree of the polynomial is 3, we also want to pick out whether or not it's odd or even numbered here. In this case, the number 3 is an odd number. Now, what that means for us when it comes to end behavior is that our ends of the graph, so we're taking a look at the left side and the right side, and those arrows that usually point off, would be going in opposite directions. So we don't know what those directions are quite yet. We'll get that from the leading coefficient, but we know that on the left side and the right side, the arrows would be pointing in opposite directions. We take a look at the leading coefficient. The leading coefficient is that coefficient that is in front of the term with the biggest degree. So the biggest degree is 3. Here, the coefficient for that is negative 5. So go ahead and circle that up and put it down here that the leading coefficient is negative 5, which is a big deal because we need to figure out, is that number positive or negative? Obviously, negative 5 would be negative. Since the leading coefficient is negative, that means that our right side of the graph, the finish line on what you would be drawing on your paper or what you'd see on Desmos, we would be finishing going downwards. So as we travel further and further to the right on the picture, we would be going downwards, and our arrow would be pointing down to the right side also. Since they're traveling in opposite directions, if the finish is going downwards, that would mean the starting location would be pointing upwards. So we would understand that because of the information we have, whether that be our degree and the leading coefficient, that these would be traveling in opposite directions. We would finish going downwards. Since it's going opposite, our graph to the left side would be pointing upwards. So off to the right, we know that we're traveling to negative infinity, going down and down and down and down. And then off to the left side of our picture, we'd be traveling upwards, going to a positive infinity.